let's continue to see how to use implicit differentiation. We have an equation, y to the fifth plus x squared y cubed is equal to 1 plus x to the fourth y. Clearly we can't solve this equation for y. So we're going to use implicit differentiation on each term. Before I get started, I'm going to point out that we have a product, x squared times y cubed. Therefore, we're going to use the product rule. You'll notice we also have a product for x to the fourth times y. So we're going to use the product rule twice. All right, we're going to differentiate with respect to x. Now I said you wouldn't be writing this like this in your work, but I want you to see what's going on. So d dx of y to the fifth plus d dx of x squared y cubed is equal to d dx of 1 plus d dx of x to the fourth y. And I'm writing it all out like that just to point out and make very clear. We are differentiating with respect to x. We were asked to find dy dx. Okay, now, in the first term, I'm differentiating with respect to x, and the thing I'm differentiating itself is not x, it's y to the fifth. I'm going to use the power rule, so I have 5y to the fourth. And then, because what I'm differentiating with respect to x is not x, I have the chain rule, so y prime is coming out. In the next term, we have, like I said, we're going to use a product rule. So let me bring this down a little bit here. And here we're going to say that u is equal to x squared and v is equal to y cubed. U prime is then 2x. Now, we're going to write it as v prime, but we are differentiating with respect to x. Therefore, we're going to do what we just did. 3y squared times y prime. That's our v prime. Applying the product rule, we have u prime v plus u v prime. And so that's going to look like 2xy cubed plus 3x squared y prime. On the right-hand side, the derivative with respect to x of 1 is 0, so we're not going to write anything for that. And then d dx, we have here x to the fourth times y. We're going to use the product rule again. U is equal to x to the fourth, v is equal to y. So u prime is equal to 4x cubed, and then v prime is equal to the derivative of y with respect to x. We call that y prime. And the product rule is what? U prime v plus u v prime. And so we have 4x cubed y plus x to the fourth y prime. Now look, I'm going to point something out. We were told to find dy dx. Dy dx is Leibniz notation for what Newton would have said is y prime. I personally don't care if you write these all as y prime or dy dx. It makes no difference to me. As far as I'm concerned, it's exactly the same thing. Now, folks, we have y prime in 3 of our terms. We're supposed to find y prime, which means we're going to solve for y prime. I'm going to skip the algebraic steps. No, I guess we'll do it. I'm going to get all of my y primes on the same side. So I have 5y to the fourth y prime plus 3x squared y prime. And then I'm going to subtract x to the fourth y prime from both sides. And then on the right-hand side, we already had 4x cubed y, and then anything that doesn't have a y prime, I'm putting on the right-hand side. So I'm going to subtract 2xy cubed. Now at this point, I am going to kind of skip a step. We're going to factor out the y primes and then divide to isolate y prime. That result is going to be y prime is equal to 4x cubed y minus 2xy cubed divided by 5y to the fourth plus 3x squared y squared minus x to the fourth. And you can quickly look at all of the terms and see that there are no common factors, so this is our answer. Now I know we're not used to having a derivative that contains both x's and y's, but here's the idea. If I had a particular point on the curve, x and y, I can substitute in place of x and y and end up with a value for the slope, which is what we would be really after anyway. Next, same instructions, use implicit differentiation. We're going to find y prime or dy dx for the cosine of x times y is equal to 1 plus the sine of y. The derivative of the cosine is the negative sine. Xy inside isn't changing, but now we have a chain rule. We need to differentiate the product xy. We're going to use the product rule, and so I'm not going to write everything down. I'm just going to refer to x is u, y is v. Are you ready? U prime v is going to be 1 times y, plus u v prime is going to be x times y prime. On the right-hand side, the derivative of 1 is 0, and the derivative of the sine of y is the cosine of y times y prime. That's the chain rule, and this is our implicit differentiation. Now, I'd like for you to take a moment to solve for y and then come back. After collecting all the y's on the right-hand side and the y primes on the right-hand side and factoring out the y prime, I get that y prime is equal to the cosine of y plus x times the sine of xy divided by y.